In this video, we're going to identify regions of sets. One way to identify a region of a Venn diagram is to shade it. So we're going to start with two sets A and B, and if we wanted to indicate that we're talking about the intersection of the two sets, then we would shade it as you see in the graph on the left. So this part that they have in common, you can see I've shaded. If I wanted to do the union of sets, then the graph on the left, I would include all of A along with all of B. I want you to recall the union includes everything from both A and B, so it should be a lot of stuff shaded versus the intersection, which was small. If I want to talk about the difference of sets, and I made sure I did both of them here, A minus B on the left and then B minus A on the right, remember it kind of just isolates the first set that we say. So with A minus B, I only want A. So nothing that also has to do with B, only A. And the same thing with B minus A, I only want B, I don't want anything that has to do with A. Okay. So let's talk about this. Could we have some kind of notation, so use some set operations to talk about what I shaded here? So here you can see the only thing not shaded is B, right? So everything else is shaded except B. Well, what makes you think about everything except B? Hopefully you're thinking complement. Because complement would say what's not in B, right? So I got rid of B. So everything in the universe not in B is called B complement. Well, check this out. Same kind of thing where I have a lot of stuff shaded and a little bit that's not. So let's concentrate on this part that's not shaded. Do you see the not shaded part here? This looks like A intersects B. Everything else is shaded. So every time it's everything else, I think complement. So this would be A intersect B complement. Right. So how about you give this a try? Could you shade A complement union B and see what you get? It's okay to do this in more than one step. I'm not thinking it always has to be one step. I just want to make sure you have everything you're supposed to have at the end. So here's what I came up with. I had A complement is everything outside of A. It includes this part of B and the rest of out here. Also, because my original question was A complement union B, when I go to do the B, I add the B back in. If this confuses you at all, I could show you some like intermediate steps. I'll have to do it kind of small. And you know how I draw by now that this would be A, this would be B. So A, B. A complement would have started with all of this stuff out here. Okay, so this was A complement. But we said union with B. So then B says I need everything in B. So that's how I picked up this other stuff. So that's how I got this pretty little picture at the end. Right. What if I want to do A union B complement? Can you picture what that looks like? Kind of start with the parentheses, A union B, and hopefully you picture it's all of A, it's all of B. But then its complement, which should say, hey, don't use A, don't use B, just use the stuff outside of it, which looks like this. Right, so just the outside parts of A and B. Okay. If I bump up to 3 sets, that's okay. So A, B, and C, I just want to make sure that they all touch each other, so I have all these nice little intersection points. And what I'm looking for here is what do A, B, and C have in common, and this is what they have in common. So here's something that's in A, it's in B, and it's also in C. So let's see if we could think about how can we describe this part where you can see it's C, but it's not A, it's not B. So one way would be to say it's C, but take away both A and B. So see how I wrote C minus A union B? That way it only kept C, it got rid of the A and the B part. Let's try again. This time let's take A intersects B and union that with C. It may help to first think about what does A intersect B look like, and then put that together along with C. So here's what I got. I can see that A intersect B, and then C added to it.